welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. I'm Alice. I'm a host at House of ZK Radio. I'm joined here today with co-host Pavel from House of ZK, who also recently joined as the communications associate for developers and for the ecosystem at Zircuit, and also our guest, Jan, who is co-founder at Zircuit. So thank you, Jan, for joining us. Really excited for today's episode.
Yeah, happy to be here. Thanks for having me.
Yeah, thank you. I'm curious if we could first start off with just like an introduction of yourself and your journey. I know you previously came from a more academic background to Web3. And if you could also maybe talk about the motivation behind building ZK Rollup.
Sure.
If there's any kind of like limitations or drawbacks with the current designs that you saw. I know that you previously focused on L2 scaling back when you were at QuantStamp. If any of those kind of led to developing Zircuit's current design.
Yeah, sure. So, hi everyone. My name is Jan. I am a co-founder and technical lead here at Zircuit. So what that basically means is, along with my other technical co-founders, I make sure that the whole network is always up and running and has the features we care about. Before joining Zircuit, or founding Zircuit, I guess as it is, I was largely an academic. I never, was a professor. I was doing my PhD, and at some point during that PhD, someone said, "Hey, check out this blockchain stuff," and I said, "Sure, that sounds way better than most part-time jobs or anything else." And so, although my PhD wasn't related to blockchain, it was in complexity theory. I got really interested in this, in particular smart contracts and sort of the early stages of Ethereum. I think this was 2018, somewhere around that year. And I did actually join QuantStamp. We were working there as a security auditor for a long time. And as I was working there, it became clear that Ethereum would never scale to, Visa level transactions per second. And it's a pretty common example, but like there was performance bottlenecks. And while the network was impressive on its own, there was a need to do something different. And so I started really getting involved in rollups, and at the time Plasma was a precursor, so I learned a lot about Plasma. And at some point, myself and some other people got some grants from the Ethereum Foundation to sort of work on topics related to rollups. So some of them was like security, some of it was compression, some of it was block explorers, basically stuff that was essential to getting a functional rollup from a prototype that maybe people at Polygon had started to talk about because they were early, or Starknet, some of these very early teams, to something that could be sort of made into a commodity. And I think, maybe now we've gone a little too far. There's a lot of them now. There's a lot of market saturation for rollups. But in part, that's because a lot of people thought of this. And when we were doing these grants, we were looking at a bunch of things. And some of it was just engineering. And we thought, okay, this is really cool. And why hasn't someone done this? Or what if we could do it differently? And some other things were like security focused and pragmatic. And, like, why aren't people doing this differently? Because like it really could make a difference, even if it means changing some of the assumptions of what it means to be in Web3. I think at the end of the day, we had so many of these ideas that myself and a couple others were like, hey, why don't we just start to do our own rollup and see what happens? Maybe we'll get a product market fit. Maybe we'll, just end up building a POC and it'll go nowhere. But let's not try to convince others of these really cool ideas, and let's have our own code base to experiment on. And I think that's how Zircuit was born. And so we sort of detached ourselves from that, QuantStamp, and now we're building Zircuit in earnest, and all on our own and all of that. And we have this product and this rollup that incorporates a lot of those practical security ideas, and the research and stuff that we've done over the years. And some of that was very much in part to the initial grants we got from the Ethereum Foundation for research, just shaping the ideas. Like we knew from day zero there would need to be a mechanism for withdrawing funds when the network is down, a so-called escape hatch. And others sort of just were content to do other approaches. And we've shipped one on our testnet, and I think it's live on mainnet now too. And then other research ideas just came from the natural sort of maybe academic backgrounds that we had. So we also do stuff on like cryptography and sort of more I don't know, theoretical as opposed to like code-based research, which is still very helpful. And I don't know how much we've shared about that. There's at least one paper I can point people to if they're interested. And then others were to get this pragmatic security approach. And that was largely the reason behind like sequencer level security, our unique sort of twist on our Rollup product. And through all of that, it seems to be going quite well. And so we're going to continue doing this, and we have a lot of ideas, and I'm sure we're going to talk a lot about them. So yeah, I mean, academic, then security auditor, and now, building a Rollup and trying to, get some really cool ideas out there. So I think that was a long introduction, but I hope that covered everything.
Yeah, and it's a great transition in between, going from the academic background to focusing on the auditing side to incorporating those pragmatic, practical, security-focused designs into current version of Circuit, even if they have, like Aziz mentioned, different assumptions than the current designs that are being implemented out there. But it's really great to see that you brought these ideas to life, like with the sequencer level security as well. And would really love to talk more about that later in the episode. And I remember, Jan, when you and I first met back in SBC, we discussed a little bit about how at that time Zircuit was planning to integrate with a zkVM, like previously, or like in the earlier designs, the design was focused more on the Halo 2 prover. So wanted to hear the motivation for Zircuit to integrate with the zkVMs. And I believe that you guys also leveraged Sindri's zkVM as an API framework for that as well. So wanted to hear about that initial motivation and also any kind of limitations that you saw with the previous designs with how you address the prover side.
Yeah, absolutely. So I'll start with a little bit of background on the existing mainnet architecture, which depending on when this goes live might already be upgraded. But it's a Halo 2 based proving system that we had initially forked from people like PSE and Scroll, and they did a bunch of like the hard work of getting a lot of the EVM to work, and we weren't content to just sit on it and like say, okay, if when they do something, we'll update it and we'll just be always following. We did actually make a bunch of modifications to it, but sometime, early this year, late last year, the sort of dream of getting a zkVM instead of a specialized zkEVM became, plausible and then feasible, and now it's sort of real and like practical and cheap. And it was kind of amazing because I think when we started it, we're like, yeah, it'll come in 5 years. It'll come whenever. And we started only 3 years ago, so I guess it wasn't that bad. But it came, and we saw this opportunity to say, okay, well, why do we want to maintain these really problematic zkEVM circuits on Halo 2? The Halo 2 system, I think, is very interesting. I like the way it's built. We built some tooling to analyze it with some lightweight formal methods, and we were definitely hiring people and getting to do research and do GPU optimizations and to improve the prover time all the time. So we weren't just saying, like, let's fork something and see what happens. We were actually making like contributions to it. I don't know how much of that was public, but we were doing this, and it became very difficult, I think, to maintain from an economic like company running point of view. Like, it's a really cool academic experience to like see what you can optimize, but when you need to also ship features, especially because your marketing team wants you to say like we should be EVM compatible, your Halo 2 circuits can never lag too far behind like Ethereum, right? Because then you can't say that out loud anymore, and you can say we're EVM compatible star, or we're something like this. And from a technical point of view, I bet most people wouldn't care. They'll say, does my smart contract work, and it'll be fine. But the marketing team really was like, no, you got to be equivalent. And I was like, I think that's fair anyways. I do have longer thoughts on like whether we should be equivalent, but I'll skip that for now. Anyways, the goal was to do that. And we started seeing SP1 come on the scene, and Zero and some others, where they said, you can just pull in Reth, which is the Rust Ethereum client, and you can just prove it. I was like, oh, that's really cool. And sometime this year, I think it was, we were like, okay, maybe we should take this seriously. And we were putting resources on it to sort of play around with it and see how good we can get the performance, and would it work? What is their marketing team not telling me? Like, what are the numbers really? What's the cost really? What's the hardware requirements? All of this, because some people really do like to try to get the deal and not necessarily tell you the truth up front. I'm not naming names. I'm not shaming people. I think just part of the industry that people try to sell stuff, and it became pretty clear that this was good, even if those people were a little bit wrong in their numbers telling us, when we wanted to go live with our Pectra update, because we had actually been building out our own version of like EIP 7702 support, which is account abstraction, which required a new transaction type. And the geth changes were not terrible, but then you had to go in and change all of the Halo 2 circuits to like specifically accommodate this new thing without breaking the soundness. And the amount of resources we needed to spend to do that was like, okay, we can't do this ever again. Like, we can, but it's gonna be, zero extra features on top of this, because we're a reasonably big team, but we're not like infinite, and we're probably not as big as a lot of other people out there. So we need to really focus our efforts. And so we wrapped up 7702 support. We got Pectra support, so we are equivalent or compatible right now. And we said, let's never touch a Halo 2 circuit again if we can avoid it. And so we've been in maintenance mode as we've started to switch to a zkVM. And we are going with Sindri. They have support for SP1 and Jolt. We're going to be going live with their SP1. They have really good proofs as a service API. I forget what the marketing team calls it, but essentially we can make calls to them and say, hey, we have this block, can you prove it? Give us the proof, and then we'll do it. And this was really helpful because it allowed us to rapidly build out this functionality, because actually a lot of what I think rollups don't tell you is that even if you're using Halo 2, or you have your in-house prover system or whatever it is, you have all this infrastructure that users don't see that like shuffles data and says, what are you proving? Are you proving the execution transaction? Are you proving a block transaction? I think on SP1 and risk, like the zkVM approach is very simple. I think you just provide the block data. But in the Halo 2 system, you could do various levels of aggregation, or did you have a super circuit, or did you have different things? And so there was all this infrastructure to just move data into the provers, prove it, aggregate them, and then write it to chain in some finalized version with whatever requirements you want, whether that's cost or timeliness or something else. And the proofs as a service API really allowed us to sort of get to zkVM without having to rebuild all of that infrastructure directly or like first. Now, that's not to say we didn't have to do some edits and that we're not going to have that infrastructure, but it meant that actually, because their service was so robust, we could just go to them and say, hey, we're going to use you to start, and we'll probably build out our own proving capabilities in-house. We'll definitely, change the bare metal servers we have currently chugging on Halo 2 to, our version of SP1 or whatever proof systems we use. But we could get there very quick. So the prototype time was reduced to like very, very little. Like, I don't think it was days, but it was certainly not years, right? So there was an opportunity to say, let's just try the zkVM and see if it works. And then using the API, we did, and it worked. And we're like, oh my God, this is like life-changing, because now we're basically at parity on that branch with EVM like all the time, assuming like Wrath or whatever goes up. And we modified Kona, which is, I guess, a succinct state transition function for state transition of optimistic rollups for our needs. So we don't want to be optimistic. We want to prove every block. I think that might have already been a feature flag there. I'm not sure. I didn't do the modifications myself. But we modified it for the rest of the circuit needs, so SLS, or proving every block, or using Sindri instead of like the succinct prover network. And we actually showed that it worked, like to ourselves. And so we have it now live on testnet, and things are going quite well, and we're planning to update to mainnet very, very soon. And I think it's going to be really, really exciting. I'm sort of hesitant to talk about like how exciting it is to like end people at like conferences, like we do booths sometimes, and they're like, "What are you excited about?" Like, I'm excited to go to zkVM. And like, why? Nothing will change from a user point of view. I'm like, yeah, you're probably right, but like from inside, it's going to be so nice that I can prove everything, quickly and have parity very quickly. Like, my developer constraints are reduced quite a bit. And on top of that, we can now reapply, different optimizations to open source provers. We can see how the zkVMs are being sort of use with ref and other things, we can play around with and do some more research on something that's actually, I think, arguably more standardized than Halo 2, because I think Halo 2 is only being used by 1 or 2 or 4 rollups, maybe 10, I don't know, some small amount. And I think SP1 and Jolt and Risk Zero and all the others will probably see like double or triple those numbers. Now, I could be wrong. That's just a gut feeling, though, that there's way more excitement about SP1 than there ever was about Halo 2. And I think there's a good reason for that. The developer experience is way better. You don't need to think about circuits and tables and soundness. It works, assuming SP1 does their job and everyone else does their job, etc., which we're confident they will.
Got it. It's good to hear that migration process was, relatively smooth. You mentioned that with Sindri's proof as a service, you were able to make those like API calls directly to just get those proofs. And you're able to use those zkVMs without having to rebuild all of that infrastructure. And you mentioned that, at least for the Halo 2 side, there was a lot just for the transferring or moving of data. And then afterwards with the aggregation and then writing the results. So there's quite a pipeline. But it's great to hear that migration process went relatively smooth as opposed to what you mentioned with the 7702 upgrade with changing all those Halo 2 circuits, making sure it doesn't break any soundness. So great to hear that migration was ended up being pretty smooth for the team. And how, like with these zkVMs, now you're able to apply different optimizations and then also do some more experimentation. So it seems like that there's a lot more flexibility with this generalized approach as opposed to the specialized zkEVM approach.
Yeah.
Mm-hmm. Oh, and one more thing to add. You mentioned there that you're currently using Sindri's zk API as a service, and then looking to switch towards running your own provers, essentially zkVM provers. I guess when running your own infrastructure, is that an important consideration? Like, would you want to run everything in-house? Would you want to delegate that to maybe like a different prover network? What are your thoughts for that?
Yeah, so I think at the end of the day, while we are a centrally operated rollup, like most rollups are right now, it makes sense to remember that ultimately me and my co-founders are accountable for the operation of the network. And, Vitalik has this great test that, can you walk away and the network will still run? I don't think Zircuit's at that point yet, and I don't think that there's a problem with that right now. I don't know that a lot of other networks are necessarily at that point right now either, which is just to say that we're all working towards this. But that point might be fairly far away. And until we get to that point, if we even want to be at that point, because I think some centralized rollups do make sense as well, you need to have accountability when you're running it, because the escape hatches that we implement are there in the worst case scenario, but we never want that scenario to happen. It's not very good for the company, but it's also it's terrible for the users, because if they were using dApps, they're no longer accessible. They have to withdraw funds. There's some inconvenience, to say the least, and there will be no guarantees of long-term ecosystem growth. And I think the purpose of a lot of these rollups is to grow the pie of the ecosystem at large. And so planning for the worst case is absolutely necessary, but handling the short term is critical, and people maybe don't want to talk about how difficult or annoying it is to run your own servers and bare metal, or get provers up for yourself, but you need to do it, especially because you are accountable for these periods of time. And this is especially true while there are no trustworthy decentralized prover networks. But even if there are, I have thoughts about that. Like, if I have a centralized sequencer and I'm decentralizing my provers, is it am I really gaining a lot of decentralization there? Or is that decentralization for the sake of a buzzword? And it's not to say we won't use one, but for now, I am certainly accountable. I want someone to sort of tell me, say, hey, your prover's down, what's going on? I say, oh yeah, I will fix this, or I'm getting on it, or we have support for it. So we are going to have probably a combination of in-house and external proving. In-house to make sure we have some baseline of prover uptime that we're definitely confident about, and external because maybe there's some decentralization that makes sense, or there's better pricing options out there, right? Maybe it's cheaper to use an API where they have servers sitting idle otherwise. I don't know if that's actually the case, but we are considering the option of doing that. It might also make sense if you have different provers, which we are going to try to build out towards the end of the year. So maybe we're not only going to be using SP1, right? Maybe Jolt or RISC-0 API. Sindri certainly supports at least 2 of those. And that will help counter issues with like client bugs in one of the provers, because if one client has a bug, we can sort of switch to another. These are things that like Vitalik and Justin Drake also talk about quite a bit. And maybe those systems have different prover hardware requirements, right? Maybe Jolt requires a ton of GPUs and and SP1 does not. I can get those numbers, but I'm just using it as an example. I don't know which one is worse for particular hardware requirements than others. But there are reasons why you might want to have diversity in your hardware as well. But ultimately, we like the idea, at least for the short term, of saying, I'm operating the network. It makes sense that I am also operating the provers, whether that's directly or with a sort of a B2B agreement that says I'm definitely going to make sure that the people I'm telling to run my servers are definitely online with very strong incentives that aren't just a chance for them to go offline and miss out on some money, but something stronger than that. And I think that's where we're headed in the short term, is to make sure that we do have some baseline uptime with trusted parties to run that, and some internal, so that again, we are ultimately accountable.
Got it. But like a combination of both the internal in-house proving as well as external, and having the decentralization and also prover diversity benefits from it. Got it. And just on the topic of prover diversity as well, I'm curious to hear about the approach that the Zircuit team took in deciding which zkVM they wanted to integrate with. So right now it's SP1. And you mentioned that, Sindri, and you're also thinking about potentially looking into Jolt and RISC-0 as well. So were there any kinds of like frameworks or models or any kinds of like specific design considerations that you were looking for, or even you mentioned cost is a big factor, or security concerns, security assumptions, or some performance metrics. What was the approach that the team took in deciding which zkVM was best optimal for Zircuit at the time?
Yeah, we definitely looked at a bunch of them, and we actually tried to first do our own in-house benchmarks to see who was sort of telling the truth on the marketing side of things. There are definitely some tweets early in the year where people were posting numbers and people were having fights about what those numbers meant. And so the best way we could figure out what was right for Zircuit was to download the open source stuff and say, hey, what seems to work with the least developer friction and the most reasonable amount of resources. Now, that doesn't mean we were looking for the most optimal solution. Like I think SP1 ended up being the fastest that were used, but I'd have to check the numbers. But it might have been 10% slower than a competitor. And if the developer experience was better, we went with that. And honestly, I think, and I'd have to double check with this team leading this effort, I think that was a lot of it. The Kona release earlier in the year or late last year, which basically said, here's how OP-Stack can be proved. And like we were based on the OP-Stack, it meant that we had to do a lot less effort. And we sort of knew that we had to make some modifications there to account for SLS and other things that Zircuit does special. And we sort of got together over a week, maybe 2 weeks, and I think the team knocked out those changes and we're like, okay, so now we're ready with SP1. And so this is great. And there were other alternatives. I don't remember. I think there's Kailua or something from RISC-0 that were close, but the Kona one I think just happened to win in terms of ease of adaptability, right? And maybe that's not totally fair, right? Maybe another week, maybe the same amount of time actually would have worked for Kailuna. But we got to a point where we were very comfortable with it. We knew all the changes we had to make, and we saw the numbers were not bad, right? They may not have been the best. I don't remember. They might have been the best, to be totally honest. With SP1, we said, this is good. So it was very much a pragmatic adoptability question rather than some weird loyalty to like the use of precompiles or something like this. And for that reason, we're also not gonna, I'm not gonna get on this call and say, hey, I'm definitely only ever using SP1. There might be a better approach that comes differently, whether that's some way we can recompile like Kona and the RISC code that it generates to a different VM to make it work on a faster or better system. Or if, Kona's not even the right answer in 6 months, maybe we can do something differently. I don't know what that looks like. I'm just saying, I think the pragmatic aspect of it is not something that we will undervalue, right? Like I think there's a lot of benefits to being able to ship well, because at the end of the day, the end users, I don't think, are changing rollups or choosing networks based on what prover network they're running. There might be some like diehard 1% where someone's like, I really don't trust prover X, and so I'm going to go with prover Y. But I would bet most end users just want to like do DeFi, trade NFTs, or whatever it is people do on a blockchain. And as long as the features of that blockchain provide them with that capability, the specific stack does not matter. And so for us, making sure we can capture the users very quickly is really, really valuable.
That's a good point that you mentioned. Like, to the end users themselves, the stack or like those specific design considerations don't really matter as long as they can, as you mentioned, do those operations that they want to do, and then also have some sort of kind of security guarantees attached to it. Then that should be good enough for the users. But of course, the stack matters a lot to your end, the engineering team's end, and it's also very interesting to hear that when choosing. The process for choosing the zkVM, it's related to the least amount of developer friction and then having the most reasonable amount of resources, not necessarily what's the fastest. And I feel like a lot of zkVMs right now, they're trying to compete on that speed portion. But you mentioned that if the developer experience was better, if it came with a smoother integration and was more adaptable, then that might have been the more optimal solution, even if it was potentially a bit slower than an alternate solution.
Yeah.
So really great to hear that. Mm-hmm.
I mean, I can add a little bit there if you don't mind. Like, I think there is very important use cases for the fastest zkVM. And I think when you put a zkVM in the layer 1, you definitely want performance to be extremely valuable. But I also don't think people on rollups are choosing, the chain based on how fast the block is generated anymore. I think in 2020 it was very exciting to talk about shaving 15 seconds off of a proof generation time. I think now everyone's content with the sort of soft commitment that the sequencer gives you, and the proof will come reasonably fast after. But if it's 2 minutes or 3 minutes, maybe I'm so removed that this is like not something that I'm aware of as being a problem. But I don't think that's the biggest issue, because that's still way better than like an optimistic rollup, which is like 7 days or multiple days, and still like significantly better than any bank, and not that worse than like Ethereum, right? Like I think if you're willing to wait 12 seconds on Ethereum, probably a lot of apps, like unless they're like really high interactivity, can wait also 2 minutes or 2 minutes and 10 seconds, or a little bit more. So I'm not saying like we shouldn't optimize all of them, but I think for a rollup use case, there's no need to sort of race to the bottom very, very quickly, especially if it means higher operating costs, which in principle, we pass on to the users. We don't want to do that. So we want cheap, and cheap might be a little bit slower, right? Maybe I can use cheaper hardware, and so it's a little bit better for the end user, even if they have to wait a couple seconds longer for a proof. For an L1, where performance matters and you need to cram everything into 12 seconds to do that, obviously there's going to be great amounts of research going into that. There was an ETH proofs call today, for example, where people were showing off all the latest stuff. And the great news is we're going to benefit from that, right? Like everyone on the rollup side will also see those advantages come, but we can right now adopt something that's a little bit slower or less optimal, but still very, very useful.
Got it. Yeah, definitely, as you mentioned, depends on that use case. Proving L1 blocks, mainnet blocks in real time is definitely would require the speed consideration to be a higher priority compared to some other use cases out there. So good that you mentioned that. Like with these zkVMs, not just considering just solo metrics, but evaluating based on your use case what makes the most sense. And I also wanted to ask you a bit about kind of the differences for rollups to use specialized zkVMs versus those general purpose zkVMs. And I think you are going to be presenting a talk related to this topic sometime soon. So maybe if you have some insights in terms of just the benefits for these rollups in migrating from using zkVMs to a general purpose zkVM, in terms of some even performance improvements, or even like improvements of the types of tasks, or perhaps even the elimination of certain tasks during this migration, or if there's any kinds of trade-offs to consider in making that decision.
Sure. So I think you might be alluding to my upcoming ETH Warsaw talk where I'm going to be talking about the actual migration we did. And I don't have the numbers of like what the performance is or how much money we have off the top of my head saved. I probably should have done that. I'm sorry. But that talk will be really describing, what it means to actually do the process, because it's not sort of just update a verifier contract and everything works. That's like the external point of view that everything sort of comes down to, but there's a lot of work behind the scenes to prep all the data. Those prover pipelines that I was talking about 5 minutes ago or 10 minutes ago, those all need to change. And what happens at the switchover point, where do you prove the last block with your Halo 2 versus the new block in zkVM? There's a lot of things like this that honestly I think a lot of rollups sweep under the rug, almost rightfully so. It's engineering problems that end users don't care about. But I think if you're going to try to talk to other developers or build out this space, having these conversations is very, very important to those developers, because we've practiced it time and time again. I don't know the count we're at, maybe 10 or 12 or 11 times right now. We've practiced this migration, and there's a bunch of steps. There's got to be some ordering to the things you do, and some components need to be robust in some ways that we didn't sort of expect, I think. I'll outline all of these at the talk. I also can't give you the specifics. I haven't finished writing the talk. But we're going to collect those ideas and do all of that. But what's easy to us might not be easy to the next chain. And if you have a commodity like framework for getting, an OP stack, which is an open source popular framework, to a zero knowledge rollup, I think that's something that you need to well document, or you need to understand how to go to that transition. Is it high effort, low effort, or high risk, low risk? Like what can go wrong? And I really like giving these talks, even though I'm not prepared for it at the moment, because it's that hidden underbelly that everyone just says, it's an engineering problem. But you can actually help 3 or 4 or 5 or more other teams with that very specific technical problem that they were trying to solve. Because ultimately, we're probably not going to be the only ones switching from a Halo 2 prover to zkVM. And any one team getting it wrong will not actually be good for anyone. Like, it's not just like, oh, that team didn't migrate properly. No, it's probably going to be like on Twitter, like, oh, rollup migration's hard. These things are challenges. ETH might drop if it's a big enough chain or something problematic. Certainly if they have a token, that token might go down. There's a lot of sort of fallout of doing this, because the ecosystem at large, I think if you move away from Web3 conferences, still, unfortunately, I think sees a lot of things about scams and like what's the use case for these systems. And they really like jumping on failures in the ecosystem to say, look, you guys don't know what you're doing. Come back to like Web 2 where you can trust us. And I don't want that to be the case for anyone in this space. So if we can practice and share this knowledge, I think it makes a lot of sense, because maybe, that's a public good. It's not a very concrete one, but the ideas and documentation about doing that. Like I would love if more rollups also shared just how their like infrastructure set up, and like how do they protect against like security risks that aren't leaking a private key. There's a lot of stuff that needs to go on that, like, when you hire a strong DevOps team, they start telling you like, oh, you got to do this, you got to do this, you got to do this, and no one talks about that out loud. And so I feel like these Web3 users are like, oh, just spin out my own rollup and everything will be happy. And it might be, but it also might be a lot of work. So I will be talking about that. I'll touch on some of the points that are a little bit specific to Zircuit there. We were very fortunate. Something I think I didn't talk about when you asked about the transition the first time is that we saw this coming. As I said, we were sort of preparing that, like, maybe zkVMs will win. But we were really in the Halo 2 camp because that's what was working for us, right? We're, again, pragmatic people. We had the provers online. And some point over the initial exploratory parts of zkVM, we thought, oh god, what's going to happen is we're going to need to go back to the original Merkle Patricia try in Ethereum, like the one that's Kesek based. And Kesek is famously bad in Halo 2. It's really underperforms. But for Halo 2, we'd built out a Poseidon-based Merkle Patricia try in our network, and we're like, so how do we reconcile this? And we were really smart. We did the thing that was probably the most engineering basic, but like it was still a lot of work. And we actually supported both tries at the same time. So we're very fortunate when we go to migrate, we could just stop using the new one that we had added and go back to the old one, and everything sort of just works. So we ended up tracking a lot more data than we needed to, and maybe our internal nodes were not as performant as they could have been. But there's this type of planning that I don't know that anyone else talked about. I talked about it in Denver at one point, and there were some interesting questions there. But I think there's a lot of these steps that if you are looking to do this migration, you can start thinking about in advance. Because if we didn't do that, migrating the state of one of our rollup to the from one track to another might have been very, very difficult. So we're very fortunate in that way.
Got it. And depends on, I suppose, each rollup's case. And in your case, when you were, at least for migrating the state part, because you were compatible with both the Ketchak and then the Poseidon Merkle Patricia try, then that integration was just a little bit easier because you just got to kind of choose the one that you wanted to use. And maybe for some other rollups, there were some different design considerations, so that migration may look a little different from them. But it's really great that you're kind of considering all of these, and Zircuit can act like as a, I suppose, like a case study that other rollups can look into if they're also thinking about upgrading from OP to ZK. So that's really great to hear, and I'm looking forward to hearing your talk as well. And I also want to talk more about the hardware side as well. So from my knowledge, Zircuit chose to assemble their own like bare metal server proving cluster, and you guys kind of had your own in-house approach there. And then you also are looking into offloading some particularly expensive operations, like for example, that are ZK unfriendly, like those MSMs or NTTs. CG like operations as well, offloading them to GPUs specifically. So wanted to hear about kind of the thinking behind how you guys are addressing like the hardware side and first adopting to that in-house approach, if there were any kinds of even trade-offs there. And then also in doing this kind of GPU optimization, and a lot of teams are also looking into this as well. There are going to be some important performance improvements if that's done, but I'm also curious to hear if you saw any drawbacks and say some overhead, especially with moving the data during the transferring, or even if it relates to like the cost side as well. So wanted to hear a bit more about kind of the thinking behind how you guys are addressing the hardware side.
Yeah, so definitely we are, running bare metal provers in-house to prove some of the stuff, and we have had to equip them with GPUs. I don't remember the exact models. I'm sorry. I have cryptographers on the team who make sure all of this runs smoothly and optimize all of those MSMs or NTTs or whatever it is that needs to be done. I don't know that I can comment too much on it right now, in part because a lot of the stuff that I was very familiar with was our Halo 2 based proving system, and we have a preprint that I can share about how we really thought about optimizing like custom gate evaluations, which were huge in Halo 2, to sort of say, here's your not quite AND gate, but something that does something more substantial within the network. And there were bottlenecks in moving data onto the GPUs, but it seemed like every time we would incur such a threat, the actual GPU performance would actually make up for it. And so we were actually able to do beneficial actions in this way, especially on custom gate evaluations. I don't have the details on that. I'm sorry. I was dreading this question, but it will be shared, and I will comment a little bit on the steps going forward, because I think that's going to go forward as well. But we have to figure out now again what that means, right? So our team has to sort of now look at how the provers for SP1 or Jolt or whatever system we want to optimize start to use these systems, in particular GPUs, in order to optimize them. So we're going to actually be sort of restarting this effort, because it's no longer custom gate evaluations, or we don't expect it's custom gate evaluations. Or maybe it is. I don't know. I'm not the cryptographer. But there are going to be new efforts where we're going to have to build out sort of our new custom in-house circuit SP1 prover, right? Not necessarily different VM, but our optimized version of actually executing that VM on the hardware that we have available to us or are available to us in the near future. And that's still early days, so I can't tell you exactly how much of the new zkVM optimizations will come, but I do think we have that preprint for the Halo 2 one, which is still kind of exciting. From an academic point of view, it's definitely interesting. From a product point of view, it's maybe less exciting now because it's no longer relevant, but I can share that afterwards.
Yeah, got it. That sounds great. But overall, like even with the attached overhead for say um, migrating some of the operations to GPUs, even with some attached overhead, you still saw the
Yeah, I
performance
think
benefits made up for it.
in every case, GPUs played a very significant role, and we were very happy to have them on board, despite any initial upfront cost or even cost of electricity. So, I think there are also efforts in sort of the ETH proofs camp to make sure that the hardware requirements are very small. For us, I'm not super concerned about that because again, we're running our own stuff. I don't need it to run on a Raspberry Pi. If I have a GPU and it means I can get a faster system without extreme expense, I'm definitely willing to take this on and try to see what we can do from it. And those optimizations might also translate to somewhere else, on lesser hardware. But we expect we'll have GPU provers all the time.
Got it. Yeah, that makes sense. And then going back to, I think one of the points that you made earlier about just like the question for decentralization, like if you're, say, decentralizing the prover, when we were talking a bit about having that prover diversity, does it really make sense if you're still, say, like using a centralized sequencer? And then one thing that I saw when just looking into Zircuit was that you guys were thinking about, or at least exploring the idea for decentralizing like the current prover cluster. And I know you talked a little bit about this as well, but curious to hear about kind of the advantages of doing so, but then also any kind of attached caveats with having a decentralized prover cluster, and then also just some other kinds of parts of the stack that say still do remain centralized, like with the sequencer, how that will be affected.
Sure. So yeah, I mean, I think for the short term, the accountability is very important. So we're going to keep it centralized, and because I'm not aware of any prover markets that are out there that I'm really, really excited to sort of trust and play around with, and then to engineer them into my network for the next month, for example, I'm definitely not doing this. But over the longer term, we're not going to rule it out. And part of the reason we don't want to cut it out entirely is that it might be actually a lot cheaper. One thing that might really benefit from decentralized prover marketplaces is this ability to leverage people's own prover optimizations. So the stuff I was just talking about that is too difficult for me to even explain, even though I've got a PhD and I'm a technical person at the company. It's not something that I know off the top of my head. So all of these prover optimizations that other very smart people will do will probably drive the cost of proving to the bottom on these prover networks a lot more quickly than it will in-house, right? In-house, we're going to have top people looking at it, but we're a small company. A decentralized prover marketplace allows the entire world to compete with these best ideas and drive prices all the way down. My concern too is that there might be some added latency in generating the proofs and pushing the data. So as you were saying about getting data to and from a GPU, the block traces might also be large. Maybe doing that over the internet might be problematic. It'll depend on the specific format and the way we can package up the sort of jobs to give out to these decentralized prover networks. But if it's acceptable, it's something we'll consider. This is something that might also be very unique to rollups, right? Again, that additional latency for withdrawals might not matter. Might mean that the latency that we incur does not matter as much as a real-time proving system. I don't know that Ethereum wants to do a decentralized prover marketplace in the L1. That seems like a chaotic mess, and I'm not saying don't do it, but I don't understand, how you'll get all the timings to work very quickly in the current state of things. On a rollup, that might make a lot of sense, right? And so if we do have other people who can provide us with cheaper proofs, it's definitely a clear win, because if we can get cheaper proofs, we can reduce the cost of transactions to the network, and we can pass those savings on to the users. So I think there is a lot of long-term potential once those networks establish themselves and have good usage. I think in the short term, I want to be accountable, and I'm okay to overpay a little bit. We actually subsidize the cost of our provers for the most part anyways, in order to make sure that the network is up and running. And if there's a bug and I need to patch a version or something, like I can push the code to the right people. On a decentralized prover network, I can probably also do that, but maybe it's different if the patch is big in some way. There will also probably be benefits when we start to see multi-prover support. I think if we see diversity in hardware requirements, we're not going to build out like an Amazon level, or Google Cloud level in-house bare metal cluster, right? Like we're not that big, so we won't be able to support every configuration that we want. So some configurations might naturally fit better on a decentralized prover network that's very specialized, and maybe we don't see them quite as often, or maybe it's a backup, or something else where it doesn't make sense for us to build it in the average case, and it's just the worst case, and we can use it as a fail-safe.
Yeah, got it. That all makes sense, and yeah, I appreciate you for also kind of mentioning maybe some of the benefits that come with kind of the current centralized approach with the accountability aspect, and then also from the Zircuit team side, you guys currently subsidize those costs of provers just to make sure the prover network is up and running. So there are some benefits there, and yeah, I do like how much focus and how much like priority you put the users in, and even on their cost side, trying to minimize their costs as much as possible. And I know that Zircuit is also security first as well. So I wanted to just transition the conversation into more on the security side with Zircuit, and some of the considerations are like the designs that you made. So wanted to hear like first with the sequencer level security. And I know you briefly mentioned that in the beginning of this conversation, and wanted to hear first the drawbacks in traditional sequencing protocols in rollups, especially those that are, say, centrally operated, that led to you and your team's design for the sequencer level security. I'm curious to hear if there's like any kind of additional enhanced security guarantees that you provide in this, and if this design can be used in perhaps like other purposes rather than just those that are security related.
Sure. So let me start by saying I'm not sure that there's a lot of drawbacks in the other centralized rollups that are being executed, right? They're essentially just trying to be Ethereum but faster, and that is a really, really compelling thing to do. Like that's what we're all doing at a rollup. But we wanted to add one extra feature, and this feature is the sequencer level security, where we actually have an AI, and it will look at transactions as they come onto the chain, or we put them into blocks, and we'll classify them as malicious or benign. And if they're benign, they go on the chain and nothing's different. So for an honest user, the UX is exactly the same. But if you're a malicious actor submitting some transactions, it'll go into quarantine. So that won't hit the chain. And that means really we get to do something that other chains can't do, which is we can determine if hacks essentially happen on our chain. And this is determined by an AI, which you have to trust in the sense that we're a centralized operator. We're operating the AI. In the future, maybe that'll be very different and we can decentralize it. I think that'll be a very difficult task, but not one that we're not considering. But what it means is that people can get extra security guarantees, exactly like you said. And that may or may not be directly as a result of the AI. Right? Maybe you like the AI, maybe you don't. I'll talk about it in a second. But the goal is to have zero exploits on the network. And if we want zero exploits on the network, it's not enough to just say we're Ethereum but faster, because there are exploits on Ethereum all the time. And going back to this conversation where I sort of said if you go outside of the Web3 sort of bubble, people say you're a scam industry, people lose money, meme coins and all of that. And I don't necessarily mean to stop meme coins. I don't know if that's a scam or an exploit per se, but there has been many iterations of bridges losing funds because someone exploited a permit function or reentrancy or read-only reentrancy or these other purely technical things where clearly the intent of the code was not let's have a clever person steal someone's funds after 6 months. Like the idea was we're going to give yield to people and people will make money and everyone will be happy. and then some bad actor who was also fairly clever came and took all the money. And those are the types of things we want to block. So they're not explicitly, I'm not really targeting like MEV where someone exploits like a 5% slippage or something like this, but something that really takes a large asymmetric value. And it's very hard to nail down what I mean precisely, actually. It's difficult because I'll give you a precise definition, then you'll fight me on it and say, what about this? What about that? And so the AI was the most pragmatic approach because we could train it on all the stuff that, made rec.news or CoinDesk or whatever your favorite news outlet was, right? If there was an article saying Protocol X lost Y millions of dollars, we knew that was a problematic thing that we wanted to stop because that was like newsworthy. That's the stuff that really drags down people's perception of the safety of the ecosystem. And so we did this. We have the AI. It's quite effective. It watches Zircuit and will quarantine transactions as appropriate. We're fortunate. No one has tried to exploit a smart contract on Zircuit, so it's been 100% effective right now. But we have pointed it on other blockchains and been able to see other hacks happen in real time, but we just can't do anything about it because we're not on that network. So it's sort of upsetting and frustrating, but we know it'll be pragmatic. And that's really exciting for a couple of reasons. First, if you're sort of a retailer, end user, or a dApp developer, you can bring your stuff on Zircuit, and now the end user has the confidence that they can put their funds in a DeFi protocol on Zircuit, even if that protocol didn't get an audit. They should get an audit. They should absolutely still do everything they can to make it as secure as possible. But if something slipped by the auditors, because auditors are only human for the most part, we can stop that. And dApp developers can also say, even if the auditor missed something, we can be pretty sure that our funds for our users will not be lost if we're on Zircuit. We have that extra layer of security. And that's really cool. But then to do more than just this type of security where we have an AI that maybe we don't trust, and this is, I think, where you're getting to with this, what else can it do? If you're a big enough sort of client, like in a B2B capacity, you can come talk to us, and we can work with you to sort of maybe write invariants for what your smart contracts should or should not do. Because maybe you're a giant bank, and although you want to be 100% secure, you do not trust an AI. And so you can come to us and say, hey, what if you had this invariant that you always enforced for my smart contract? And it'll only affect my smart contract, so I'm not super concerned, about centrality or censorship of other people's transactions. It's just, if people interact with my contract, these are the rules. And we can work with you to build those out. This also means we can enforce things that aren't strictly security if we really want to. So you could imagine calling smart contracts being allowed only from particular whitelisted addresses, enforced at the sequencer level, not the smart contract level. Now, I don't think we want to go down that route because then we stop becoming EVM equivalent quite quickly. But if there is, a suitable set of rules or a good use case for this, we definitely can. And I think it's really exciting that once you start to sort of look into this centralized operation of a rollup, you can play around with what's possible, right? You can make additional features and do different things that, as long as you don't sort of diverge too far from the norm, at least not too quickly, you can let everyone who doesn't want the optional features to be just getting a better experience in terms of some extra layer of security, especially if we're just as cheap and just as fast as anyone else, which we are. But if you do care about some very unique functionality, there's a way you can come talk to us and we can try to make this work. And I think this is going to be really valuable over the next couple of years as the market space becomes very, very saturated, right? We're already at 100 rollups. SLS is one way we can uniquely say this is what we're doing differently. And I think other rollups will need more and more of these. And institutions who want to come on chain will be faced with the build or buy question that they always have for any tech, right? It'll be, do they build their own rollup with some custom functionality? Maybe, if they're big enough, they got the resources, they want to do it, they have a big enough change set, maybe it's worth doing. In the other case, they could just come to people like us who are willing to say, okay, actually you have special requirements, let's work with you. We're not necessarily going to do everything under the sun, but we can definitely change some things for your benefit, like these invariants, this extra security. And if you do that, that means you get access to our ecosystem without having to rebuild it yourself, because one of the downsides of building a new rollup is, ecosystem and liquidity fragmentation, right? How do you get users onto your chain? If you come to an existing chain, you don't have that problem. But if you go to a chain that is like definitively only Ethereum but faster, then maybe you don't get the feature set you want. So there's, I think, a really good trade-off, and so Zircuit can do that for institutions and enterprises if there's a need for that. And I think that's really exciting. I think that'll be one way we can differentiate ourselves going forward. And I think there'll be a really big demand for that, actually. I really think there's an underexplored market for trying to do things differently for the right reasons. And yes, you have to trust the for the right reasons part, but honestly, trusting an institution on-chain still gives you more off-ramp ability than trusting an institution off-chain. So I think this is a good middle ground that, especially over the next 5 or 10 years before we see full decentralization sort of go everywhere, is very, very interesting.
Got it. And it's good to hear that the team also, the Zircuit team also offers this customizability, option for some other teams. Like if they have any special requirements, you mentioned like those invariants for smart contract. If say you don't trust, like currently there's like an operator who is handling the AI to monitor transactions and to say do the quarantine functionality if needed. But if they don't trust that AI, they can have their own kind of requirements that they want to follow that the Zircuit team can help assist on. And at the same time, if they have that integration, then they also have access to the Zircuit ecosystem and don't really have to build their own entirely from scratch, from what I'm hearing. Mm-hmm.
That's right, yeah.
Got it. Yeah, and it's good to hear that there's kind of also, in addition to that extra layer of security that's guaranteed to users. And also just curious because I know that there's quite a lot of L2s also thinking about or have already integrated with decentralized sequencer models. And for the SLS design, currently to my knowledge, it's mostly based on a centralized operator. So curious to hear if the SLS design can also be applied in a decentralized setting as well.
I mean, I think the short answer is yes, eventually. The longer answer is the current implementation that isn't sort of invariant based is AI. So decentralizing an AI is going to be very difficult. Or we have to give up that requirement and just become like any other rollup, or have people opt into this on a validator type arrangement. But I think that's going to weaken the security guarantee of it quite a bit. So I think there's long-term plans to figure out how to do this, but in the short term, the reasons to do this don't make sense. First, we trade off that sort of B2B type enterprise customizability. Second, we're seeing people like Tycho and others try out based rollups, and the first attempts were very expensive and very inefficient. And we don't want to be strictly followers on a lot of these things, but like the numbers were quite bad that we didn't want to like put the resources into building it just now. Now, the numbers I am thinking of are probably already close to a year old, so maybe it's gotten significantly better and we will reevaluate this ability to do it. But then getting the AI on chain or decentralized might still be a blocker for the short term. There are ways you can engineer around that if we really want to go down that route. We can say anyone can sort of propose a block, but maybe then the sequencer will have a centralized AI that will slowly over time do its job anyways. But none of these seem to be strictly like beneficial other than for the sake of saying we're decentralized, which I think is like a good long-term goal, but it's not something that my end users or other people are telling me that I'm missing. And I'm not trying to say that like go spam my Twitter and tell me that I should be decentralized. Like, I mean, you can do that, but I really think that there is this middle ground where you want some accountability, and the easiest way to do this is this type of centrally operated system for now. And it means cheaper transactions and faster upgrades. And so we will, progressively get more and more decentralized. I think that's the plan for almost every rollup, and we're certainly no different there. But the AI's technical challenge for that means that we have to tread carefully about this and make sure that the use case is very, well validated before we expend the resources to do that.
Yeah, and another point is that we trust auditors and we trust networks L2s with the fund with funds. Essentially, like this doesn't deviate with what people are currently using layer 2s and other applications for.
Yeah, that's right.
Got it. And yeah, there's also those kinds of benefits that you mentioned with the accountability and even the B2B type customizability that's currently possible because of the centralized operator. But if we begin to go towards a decentralized approach, that won't be as straightforward to do. And even right now on the user side, users are experiencing cheaper transactions, and on the team side, enable for faster upgrades. So it makes sense. Like for now, the Zircuit team has still chosen to kind of use the centralized operator approach, but is thinking about perhaps decentralizing in the future when the time comes.
Yeah.
So good to hear those insights. And just as like a last question before we close today's session, I really enjoyed diving into all of those technical details, but curious to hear if there's any kinds of announcements that you'd like to make on behalf of Circuit, or if there's any kinds of, say, advice that you have for some roll-up teams in the audience potentially who are listening to this. Just any kind of like last thoughts or last takeaways.
I don't know. I'm not a good marketing person. I'm just hoping I didn't say anything bad on the whole call. No, I think the announcements are zkVM will come very, very soon on Zircuit. So possibly, like I said, this by the time this is aired, it may have already happened. It's on testnet, so it's coming. And then we'll also have some more user-facing applications coming. I believe they're in the works. I am not on that product team, so I am not going to ruin anyone's dreams by saying something that could be incorrect. But stay tuned to our Twitter, and we can definitely figure it out. To the roll-up teams, keep sharing the work. We like to share our stuff. We publish papers. We like it when you do too. Not because we want to take the ideas and steal them, but because actually there's a lot we can learn. And even things that you think are boring and uninteresting, I guarantee you there's like at least 3 or 4 other teams that have been having the same issue and would love to collaborate or use your solution or contribute a solution to you. Everyone says let's build together, but very few people do. Admittedly, we got to open source our code still, but we're coming. It's going to happen, and we want to keep collaborating with people. And I think everyone benefits when we all try to grow the pie together. We're maybe individual companies, but we're all building the same Ethereum ecosystem, and I think that should come before any particular issue you're having on a rollup.
Right. We're all kind of building our own individual companies, but at the end, the end vision, end goal is the same. So really like that ending note that you had there. And yeah, really enjoyed this conversation overall. Really liked going into all the kind of the design considerations, the thinking behind them, kind of the trade-offs that the team saw based on your own kinds of priorities with what you wanted for your design, especially with the zkVM upgrade, and then even the security side as well. So it was really great to hear all those insights from you. Thank you so much, Jan.
Thanks for having me. Thank you.
Yeah, thank you.